Time to finally do a couple of these coordinate proofs that we've been working up to. I'm going to go over two examples of how these coordinate proofs work. The first one I will do I introduced last section when we set out a plan for it. This should all look familiar. This is a proof of the theorem that says the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. Let me reorganize things a bit so we have a little bit more room to work. That's better. I'll give you a second to adjust, but this is all the same information. But now most of the room is ready to fill in with the guts of our proof. This was our plan from last time. Our first step in the proof was we were going to use the midpoint formula to find the coordinates of m. Now we actually have to do the math to figure out the coordinates of m. This is what the midpoint formula gives us. The midpoint is at AB. The next step in our plan was to use the distance formula to find those three lengths. This is what those three distance formulas look like. You can pause if you like so you can make sure you understand how I got those, but they are just simple distance formula calculations with the points from the picture plugged in. I have highlighted the conclusions to showcase that all three formulas result in the same thing. This is what we needed to show so that we have reached our prove line, and thus the theorem is true. This theorem can also be proved in other ways, but this is what it would look like in a coordinate proof. Instead of two columns or a paragraph, we have a statement followed by the math to support that statement. Keep doing that, making statements and then supporting them with the math until you get to your prove line. That's how a coordinate proof works. Let's do another example. Here is the triangle midsegment theorem from chapter 5. I am sure you remember it well. In order to prove this theorem, we have this given and prove lines. This was one of those few proofs with multiple things to prove, so we'll need to deal with both of them one at a time. Now let's work on how we will do this. The given statement talks about two midpoints. That should be screaming out to you that we need to use the midpoint formula in order to find out what the coordinates of D and E are. This is what those calculations look like. You can check for yourself if you like, but you definitely need to be able to do these kinds of calculations. Let's put those points in our picture. Now what do we do next? The first part of the proof is to show that DE is parallel to AB. The first part of the proof is to show that line segment DE is parallel to line segment AB. That should be telling you the next step is to use the slope formula to do just that. In a coordinate proof, we need to show the math behind it to show that it works. Make sure you realize with these calculations that since the numerators are 0, then the whole slopes are 0. These slope formulas have just shown that these line segments are parallel since their slopes are both 0. Now we need to deal with the second part of the prove line. The second part needs us to show that DE is 1/2 of AB. We need to use the distance formula to do that. Time to actually churn out those distance formulas. You should end up with these answers. Notice how AB is twice as large as DE. That's what we needed for the second part of our prove line. That's all for our coordinate proof. On one page, this would take up quite a bit of space to list it all out, which is why it was so hard to fit it all here. Hopefully, this will have given you some sort of sense about how these proofs work.